Derivatives of trig functions, part 5. Here are the trigonometric derivatives that you'll want to make sure you know. We want to differentiate f of x is equal to sine of x minus cosecant x all over tangent x plus 4 to the x. So this is a quotient, and we'll have to use quotient rule. It's a relatively tricky function, so it might be helpful to find the derivative of the numerator and denominator before we actually go through the quotient rule process. So the derivative of our numerator is the derivative of sine, which is cosine of x, minus the derivative of cosecant x, which is cosecant of x times cotangent x. So we have cosine of x plus cosecant x times cotangent x. And we'll also want the derivative of our denominator, the derivative of tangent x is secant squared x, and the derivative of 4 to the x is 4 to the x, natural log of 4. And now we can use the quotient rule to find our overall derivative of f prime of x. This will be equal to low, so tangent x plus 4 to the x, d high, so the derivative of our numerator, which we found was cosine of x, plus cosecant x, cotangent x. So we have our low d high. Now we need our high, which is sine of x minus cosecant x times d low, so the derivative of our denominator, which was secant squared x, plus 4 to the x, natural log of 4. So we have the top of our quotient rule done. All that's left is to be able to draw a straight line, maybe. Close enough for practical purposes. So low, so the derivative, not the derivative, so our denominator, which is tangent x plus 4 to the x, all squared. And that is f prime of x for that function. So we have g of x is equal to 2e to the x times cosine of x plus 3 root x, and this is a product. So we will need to use product rule to evaluate it. Let's real quick rewrite that 3 root x. So we have 2e to the x times cosine of x plus 3x to the 1/2. And now we'll use our product rule. So g prime of x will be equal to the first function, 2e to the x, times the derivative of the second function. The derivative of cosine of x is negative sine of x. The derivative of 3x to the 1/2 will be 3 times 1/2 times x to the negative 1/2. Then we'll need to add our second function, which is cosine of x, plus 3x to the 1/2, times the derivative of the first function. The derivative of 2e to the x is 2e to the x. Simplifying this a bit, we can factor out our 2e to the x. And then we have negative sine of x plus 3 over 2 root x plus cosine of x plus 3 square root of x. And this is g prime of x. Given f of t is equal to secant t, find f double prime of pi over 4. So we'll want to find the first derivative, and then we'll want to find the second derivative. So f prime of t is equal to the derivative of secant t, which is secant t tangent t. So now we have secant t times tangent t, so we have a product, which means we'll have to use product rule when we take the derivative of our first derivative to get our second derivative. So that'll be the first function, secant t times the derivative of the second function. The derivative of tangent t is secant squared t, plus the second function, tangent t, times the derivative of the first function. The derivative of secant t is secant t tangent t. So we have secant cubed t plus secant t tangent squared t. And we could probably factor things out if we wanted to, but we're just trying to find f double prime of pi over 4, so if we want, we can substitute from here. So this will give us secant cubed of pi over 4 plus secant pi over 4 times tangent squared pi over 4. If you're a little stuck on your trig and you don't know how to evaluate secant immediately, we can rewrite the secant as 1 over cosine cubed pi over 4 plus 1 over cosine of pi over 4. Tangent of pi over 4 is 1, so we have 1 squared. So this is equal to 2 over the square root of 2 cubed plus 2 over root 2. So those are the reciprocals of the cosine of pi over 4. So this is equal to 8 over 2 root 2 plus 2 over root 2, which is equal to 4 over root 2 plus 2 over root 2, which is equal to 6 over root 2. And this is acceptable, but you'd probably want to rationalize it and get 3 root 2. So this is f double prime of pi over 4. Now for some of my favorite problems, which are finding the manyth derivative for functions. In this case, we want to find the 95th derivative for f of t is equal to sine of t. Now, if you're asked to find maybe like the 5th derivative, you might just want to take 5 derivatives. But if you're asked to find the 95th derivative, you don't want to take 95 derivatives, and I don't want you to take 95 derivatives either. Instead, I want you to take 4 or 5 derivatives and try to find a pattern. So, f prime of t will be equal to the derivative of sine of t, which is cosine of t. Jumping ahead there. The second derivative, f double prime of t, is equal to the derivative of cosine of t, which is negative sine of t. The derivative of negative sine of t, so our third derivative, is negative cosine of t. And then the derivative of negative cosine of t is sine of t. But we've already seen sine of t. So as we keep taking derivatives, we're going to find that we're looping. And it takes 4 different derivatives to complete a loop. So we take 1 derivative, 2 derivatives, 3 derivatives, and then on the 4th derivative, we're back to the beginning, hence that 0. So if we're trying to take 95 derivatives, we have to figure out how many loops we're taking and where we end up with. So let's see, it takes 4 derivatives to make a loop. And we need to find out how many loops we have and how many leftover derivatives we have, if any. So if we're taking 95 derivatives, that means we're dividing by 4 in order to figure out how many loops we have, since there's 4 derivatives per loop. So if we divide 95 by 4, 4 goes into 9 twice, with that 1 left over, carry down the 5, 4 goes into 15 3 times, with a remainder of 3. So that means that we have 23 loops and 3 extra derivatives. So we're going to go through this loop 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth until we get to 23 times. And then we'll take 1, 2, 3 more derivatives. And so the 95th derivative will be negative cosine of t.